So let's dig a little bit more into the social science perspectives on Earth system and specifically climate change. So this is one framework called DPSIR framework. I don't know if they call it DIPSR or something, but it's looking at driving forces in society, pressures, state change in environment, impacts on society, and response. That goes into DPSIR. So it's looking at agriculture, industry, energy, transport services, households, and the pressures on land and resource use, emissions, technological risks, state change, of course, in terms of physical, chemical, and ecological degradations, impacts, environmental goods and services, and human well-being. So this is already different. Climate impacts here are not necessarily just on agricultural yields, increasing extreme events, floods, sea level rise, etc., but to actually look at environmental goods and services. This is where the difficulty also comes in terms of translating natural science models, physical Earth system, physical biogeochemical Earth system models into ecosystem services. How to value non-market goods, for example, a forest or a coastal region, etc. Right? So human well-being, that's even more difficult. Okay, so in terms of response, it considers adaptation, mitigation, remediation, and compensation. So those depend, of course, on sector policy, environmental policy, statement of objectives, and social prioritization. So remediation cannot be done unless there is a statement of objectives that relate to the societal the state change in the environment. Okay, that's where the wicked problem kind of issues come in. I think I didn't put it on display. Sorry. I hope you can still see it. Okay, so this is the so-called resilience cycle in socio-ecological systems by Holling and Gunderson. Holling led this kind of thinking early on. So this is showing the potential and connectedness of the socio-ecological systems, and the definitions I'll show in the next slide. Here is a reorganization which has less connectedness but high potential. Exploitation obviously happens when you have low potential, low connectedness, and release, we need a definition for this, and of course we understand conservation, which is high connectedness and high potential, with this kind of loop going through change, growth, stability, and crisis. So in terms of definition in this panarchy model as opposed to hierarchy, for example, so it's multiple connections at the same time and not a linear hierarchical connection. Exploitation stage is one of rapid expansion, as when a population finds a fertile niche in which it to grow, like let's say at the end of the last ice age, and the beginning of the modern human being and the agricultural lifestyle. We spread out and exploded in population after industrial revolution, especially looking for these fertile niches around the planet. Conservation stage is one in which slow accumulation and storage of energy and material is emphasized, as when a population reaches carrying capacity and stabilizes for a time. So population itself has to stabilize. The release occurs rapidly, as when a population declines due to a competitor or changed conditions. So you can think of civilizations going extinct, whether it's the Harappas in the Mohenjo-Daro region, Mayas, Incas, Babylonians, Mesopotamians, whatever, who had been exploiting the resources, and then the pressure is released when the population decreases or they move. Reorganization can also occur rapidly, as when certain number of members of the population are selected for their ability to survive despite the competitor or changed conditions that triggered the release. I don't know, you can think of the Vikings, which colonized the Greenland coasts where agriculture was possible, and probably the able-bodied ones survived by maybe leaving, whereas the ones that decided it's too late to move went extinct, right? So the social science perspective of Earth in that sense is important. So these are the kind of figures that were used in the early 2000s and late 1990s, where Diversitas, which focused on biodiversity, International Geosphere Biosphere Project, which worried a lot on marine ecosystems and biogeochemistry, International Human Dimensions Program that we mentioned before, and the World Climate Research Program created this Earth System Science Partnership, which was to worry about global sustainability of water, food, carbon, and human health. Okay, so ISSC global changes here, then IHDP cross-cutting themes. This is the International Social Science Council or some such thing. Global environmental change, poverty, equity, inequalities, and global economy, population and demographics, social unrest and violence, and urbanization, which continues to be a big player in terms of impacts to climate and from climate. IHDP, which is now merged with along with IGBP and so on into Future Earth, worried about vulnerability and adaptation and resilience. We will visit this a little bit more. Governments and institutions, social learning and knowledge, thresholds and transitions. Okay, so basically the social science perspective still kind of remains a barrier for natural scientists who do the climate modeling enterprise is huge now, especially under IPCC. There are working groups under it worrying about adaptation, mitigation, so technology and parts of the social science, but social science is not funded at the same level that the modeling enterprise is funded. Okay, this tends to be an issue as well for the real integration of social science and human agency into Earth system models. We'll look at it a little bit more.